This is Algebra 1, Semester 1. It's a unit called Inequalities. It's the second unit. And it's a lesson 04. So the fourth lesson, Solving Inequalities with Times Division. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find it. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Here's the website name, creatormath.weebly.com. When you Google it, type that in. Homepage should look like this. There it is. Anything to do with the composition book, you guys, just scroll down, find the words composition book. Please follow all the directions here, watch all the videos, follow the deadlines, and put all the notes in according to what pages they go on, and you should have a 90 to 100% on your composition book. For the actual notes and vocabulary practice and problem sets and video lessons, please click the tab of the class we're in this case Algebra 1. Here is the PDF with all the vocabulary for this entire school year. So if you're not getting 100% on your vocabulary practices, please make sure you know how to access this PDF. You'll save it to your device. Google how to search a PDF on the type of device you're on, and it will tell you. Each device is a little bit different. Let's see, we're going to scroll down to the semester that this video is dealing with. In this case, it's here. This is the table of contents for this semester. You should have already copied every line of this table of contents for this semester into pages 2 through 6 of your composition book. If you haven't done that already, please stop and do so. Watch the videos on how to number your pages. Watch the videos on what a great composition book looks like. Now we're going to find this unit right here, Inequalities, and this is the fourth lesson. All right, so we're going to look for the fourth lesson right here. 1, 2, 3, 4. Solving inequalities with times division. Here are the page numbers in your comp book where these notes go. Please don't take this video's word for it, but go and find the original table of contents at the time you're watching this. These page numbers probably will have changed. We're going to click notes just to look at those really quickly. Sometimes it takes me twice to open those up. Please copy these problems into your comp book. It's going to show you how to solve, or you're going to write out some sentences here in math on how to solve these inequalities. And then we're going to go over a problem set right now that helps you see it a little bit more real time. But you need these notes in there. Try to figure out what you're looking at in terms of if x is less than or equal to 56. Look at the graph. Look at the set notation, which we'll talk about too. And this does have some hints in here on things like, just like with an equation solving, reverse operation works to isolate the variables. When multiplying or dividing by a negative, then the inequality flips signs. That's kind of written sort of innocuously there, but that's a big deal. When solving where you divide or multiply by a negative, on each side of an inequality, the actual inequality sign flips. I'll show you a couple examples of that. We'll talk about that as we do the problem sets. All right, let's go quickly through these. This means greater than. This means less than. This means greater than or equal to. This one's less than or equal to. And I'm only going so quickly, you guys, because they've been on every lesson so far. So go back and watch the others if you haven't already. On a number line, what does an open dot mean? The value is excluded. We've talked about that too in prior lessons. If you have a solid dot, what does it mean? So on a number line, what does a solid dot mean? It means the value is included. We'll show examples of that in some of the problems we do. Given a parentheses, what does it mean? It means the value is excluded. This is in set notation. Again, this is our fourth lesson, so we've talked about set notation quite a bit, and we'll show examples of that. Given a bracket, it means the value is included. So you have an open dot, solid dot, and you have a parentheses bracket, right? All different ways of showing that something is included or not. And by the way, you have just a greater than or less than for this, and you have a greater than or less than or equal to and a greater than or equal to. So this has equals to show included, bracket to show included, solid dot to show included, open dot to show excluded, parentheses to show excluded, and no equals to show excluded. So I hope you're saying there's different ways to represent exclusion or inclusion when it comes to discussing sets and values. Given a positive infinity, how is this read? Positive infinity. Given a negative infinity, how is this read? Negative infinity. Is infinity a number? No. It's a concept, okay? It's a concept. It means that numbers are either increasing forever or decreasing in the case of negatives forever. All right, so we'll deal with that. And looks like we only have 3 problems here, so we'll take a little bit of time for each of these. Let's do 14 is greater than equal to x over 4. So we know to solve this even like a regular equation, we'd multiply both sides by 4. Right? The 4's cancel out. X is less than or equal to 4 times 14 is 40, 56. So notice they've got it in this orientation. X is less than or equal to 56. Is that what this says? Well, I can look at it backwards and say x is less than 56. And inequality can be read from right to left or from left to right. We can say 56 is greater than or equal to x. We can say that too. We can also flip these. So I think I said in my last one, in a sign at a gas station or whatever, right? Whatever this says here. This entire sign flips, right? So now you would see it reverse if it was see-through. This entire statement flips. So the x comes over here. The small side is still toward the x. It remains toward the x. The sign flips too, and the 56 comes over here. So x is less than or equal to 56. Yes. Let's represent it on a number line. Here's 56, here's 0, and it's less than or equal to. We need a solid dot to show equal to. And it's going down off to the left, this way, forever. All right, so how far is it going to go? Now let's do the set notation. Let's do bracket 56 because the 56 is included, comma. And it's going down forever, which would be negative infinity and a parentheses because you can't include infinity with a bracket because infinity is not a number, it's a concept. This one does include 56 because it says equal to. The x has to be also equal to 56, which means a solid dot. So this one here too, negative infinity. All right, so 9x is less than or equal to negative 90. Divide both sides by 9. X is less than or equal to negative 10. That's this one. Set notation, well, let's draw the number line first. If this is 0 and this is negative 10, and this is less than or equal to 10, we need a solid dot, because it's equal to. And then we're going off in this way forever. Okay, so bracket-wise, we want to bracket the negative 10, comma, and just see how my brain works. It is working backwards. It's starting with what I know, that the 10 is included, therefore the bracket, comma. It's going down forever in the negative direction, parentheses. I have to write it in the direction of, hey, it's heading that way forever, right? I can't use a bracket with an infinity because infinity is not a number. You can't include something that's not a number. All right, now let's get to the harder case here, which is a little bit challenging. So in this case, we have a negative x, and anytime we multiply or divide by a negative, it flips this sign. And I'm going to show you why here in 1 second. Let's go ahead and do it sort of the old-fashioned way first, then we'll move to the hint way. And I hate hints on some level in math because students rarely remember them. But at the same time, it's so much nicer if I can just sort of summarize this into a consistent statement of if I multiply or divide by a negative with an inequality, I flip the sign. That works for me. All right, so I'm hoping maybe you can see the wisdom in it. But I'll show you why here also. All right, let's do this. Let's multiply both sides by 9. 9 over 9 is 1, so I'm left with a negative x is less than or equal to negative 90. Right, so I've got a negative on both sides. Here's how we would handle this in equation solving. We would add an x to both sides, and we would add a 90 to both sides. All right, what happens is the 90s cancel on the right, the x's cancel on the left, and you're left with now 90. The sign drops straight down, and we're left with an x here. So notice the real answer to this thing is x is greater than 90, but it took just this old-fashioned sort of adding to both sides, which is fine, we can do that. It becomes a little bit problematic with a compound inequality, so I kind of prefer to say, let's just do this a little bit quicker. If it's x over 9, let's start again, right? I'm going to multiply both sides by a negative 9. When I multiply both sides by negative 9, this sign must flip. So instead of being a less than, now it becomes a greater than. The negative 9 times a negative x, the 9's cancel out, negative is positive, the x is here, and this becomes positive 90. So notice x is greater than 90, check. X is greater than 90, check. I kind of like this hint method better because when we get into a little bit more complicated inequalities, this just serves me better. And look at how much faster I did it. But what's really happening is exactly what we did here. Just rewind the tape and watch it. We had to add x to both sides, and we had to add 90 to both sides, and that produced the x on the right greater than 90. So instead of moving the pieces from different sides, we flipped the sign and saved ourselves about 2 steps there. Oh, I guess it'd be nice if I did this. That's annoying. So notice we multiply both sides by the negative 9, and that flipped the sign here from less than to greater than. Then the negative times negative was positive, and the negative times negative was positive. So x is greater than 90, and x is greater than 90. Right? So we got the same answer both ways, just the second way is a little bit cleaner. X is greater than 90 is here. Let's do the graphing. Let's do this. X is greater than 90, so let's say this is 0, this is 90, x is greater than is an open dot off to the right. Okay, so it would be a parentheses 90, comma, going all the way up to positive infinity, which is not a number. So 90, comma, positive infinity, 2 parentheses. Can we still see it here? Right here. So this is the set notation. And this is the reason why when we multiply or divide by a negative, we flip the sign, and because this whole thing occurs and the sides actually switch while the sign stays the same. This way, we keep the sides the same and switch the sign. All right, make sure you're matching up the title of the video with the problem set you're doing. Otherwise, this won't make much sense. This is Algebra 1, Semester 1. It's the second unit called Inequalities. It's the 4th lesson called Solving Inequalities with Times Division. It's on creatormath.com. under the Algebra 1 tab. Hope that helps.